Assalamualaikum warahmatullah. So today we're going to discuss about the derivative from ideal gas law. So as you all can remember, I believe you remember, the ideal gas law is denoted by PV equals to nRT, when P stand for pressure, V volume, N number of mole, R is gas constant, and T temperature in Kelvin. So how we can derive density and molar mass from this PV and RT? Okay, so take note, our initial equation that we're going to use is PV equals to nRT. This supposed to be our header. Okay, so PV equals to nRT. So first we would like to find, let's say, density. So what is density? Density is mass over volume. Okay, so if you look here in PV and RT, there is no mass. Okay, there is no parameter that denote mass. So what we can do, how we can calculate density from PV equals to nRT? Okay, so first I want you to recall how we can calculate mole, right? So mole, I change the color. Okay, so mole equals to mass over molar mass. Okay, so mole equals to mass over molar mass, or in this case we use as N. Okay, so N equals to mass over molar mass. Alright, so now what we can do is we substitute mass over molar mass inside the PV equals to nRT. So our new ideal gas law will look like, okay, remember, we substitute N with mass over molar mass. Okay, this N I substitute with mass over molar mass here. So it is equal mass over molar mass multiply by RT. Okay, again, so we rethink. Okay, what we want now is density. Okay, so our aim here, we want to have a density where the equation for it is mass over volume. So is there any mass in our new PV and RT? Yes, we have mass here. Do we have volume? Yes, we have here. So what we need to do now is actually we just need to rearrange. Okay, we need to rearrange our equation so that we have mass over volume equals to what? Alright, so mass remain there. So molar mass we bring up here, right? And then volume we bring down here. But what we want is mass over volume. So RT we must remove from this side, multiply, so this side become division. Okay, MP over RT. So can you see mass over volume? So this is our density. So whenever you have molar mass, pressure, constant, and temperature, actually you can calculate the density of a gas. Okay, so if I rewrite this, it's actually, you can find density equals to mass over volume. But when we do the example, or when we do the exercise, or the problems actually, the problems in gas law, we normally don't have this, but we may have molar mass multiplied by pressure divided by R constant and temperature. So please be careful with the unit, where pressure must be in atm, R must be in L dot atm over K dot mole, and temperature must be in Kelvin. Alright, so that is how we can calculate density. What about molar mass? Okay, so molar mass is even easier than that. Okay, so the same thing happened. Okay, so we have PV and RT. We have PV equals to nRT when mole equals to mass over molar mass. Okay, so now we substitute our mole with mass over molar mass. So we have here PV equals to mass over molar mass multiplied by RT. So now what we want is molar mass. How we want to calculate molar mass, alright? So what we can do is we just rearrange the equation, okay? So how we can rearrange our equation? Just like before, what we want, we bring it to one side. Okay, we want molar mass, so molar mass stay here. PV, put it down here. Okay, so molar mass equals to mass multiplied by R and T divided by PV. Okay, so this is how we can calculate mass, molar mass, here we can calculate molar mass as well as density of gas, derived from basic PV equals to nRT. So I hope this short video give you very clear indication on how to calculate density and molar mass, and I hope you can apply this and do your exercise easier. Thank you.